Hello, everyone. So here we are at another exciting, rollout session for upcoming HyperStudy version 2023.1. I'd like to thank you all for your attendance and interest in the upcoming features and enhancements. I hope you'll have a good session with us. This is basically the agenda of the rollout session, and the main categories for the enhancements and improvements in our product will be graphical user interface, connections, methods and tools, post-processing, visualization, and some noteworthy bug fixes and announcements. All right, so the first category I will dive in with is the GUI. I'll start with the changes to our GUI overall, the look and feel of it. So in this release, we're introducing an option of ribbon style interface besides the classical one. Just to mention, the classical version will be still available. If you go to Start menu, you will see two options, HyperStudy 2023.1 and HyperStudy Classic 2023.1. So obviously in terms of the icon, you'll see a little C in the right bottom corner. That will indicate that it's a classic version. But going forward in this session, I will demo all these features and improvements in a new interface. So if I were to show the new interface to audience here, as you can see, we have some large ribbon options in the upper portion of the GUI, and also we have some changes to the menu. So if you look at the file options here, pull-down menu, it's very similar to Unity interface. So we don't have the preference definition here. For example, you have to go to preferences and go to the HyperStudy section, and picking your user preference file or display precisions can be like configured here, or the profile type you're interested in. So overall, the look and feel is going to be similar to the Unity interface. Also, now we have this view option, the ribbon here, so you can activate, deactivate some browser options. And up until this release, we had the Study Explorer and the Study Directory always like side by side. Just bring it in here. Now you have the option to stack them up on top of each other. It can be either way. Study Directory can be up here, Explorer can be down here. Also, you can activate, deactivate the message box area again from the view option here. And like I said, you have the classic option now, as well as the Unity or ribbon style interface here. Okay, the second category is the connections and integrations. In this area, we have only one update, which is the introduction of the physics AI model type. So previously trained models can now be deployed within HyperStudy as a solver process. And I'll straight dive into the demo here. I have this nice example of showing the physics AI you use in HyperStudy. I have just to give you a brief definition of it. So I have three models here. The first one is a parameterized file type, which is responsible for generating the input deck file for the subsequent physics AI models. The second model here, which is the physics AI model responsible for the displacement predictions, and the third one is responsible for predicting the stress values. All you have to do is, it's very simple setup. You just point the resource to the respective PSMDL physics AI model type, and define the input file in the solver input argument section. Yeah, and there's no solver execution script here. Everything is internally processed, and once you have the connection or linking of these input files to the subsequent model types, and you're good to go. And you will have to still define your data sources manually, and output responses, scalar type of responses. But in terms of setting up the model, it's pretty easy. Nothing complicated. And for those who are wondering, we will bring in the capability of training physics AI models in the near future. Okay, the second category, methods and tools. We have a total of 6 major enhancements in this field. The first one is the introduction of a new method to analyze parameter sensitivities The new method is called global sensitivity analysis, and it's based on Sobol indices. Uh, I don't want to get into the technical details, but the sensitivity index in the scheme includes both individual and all interaction effects. So we don't have any distinction. Once you go with it, you have the main and the interaction effects all combined in the visual area. Uh, Basically, this method what it does is it just decomposes the each response and distributes the decomposed variance into input space, and each individual gets its share and displayed similar to to the methods we have previously. Um, so I'll also demo this one quickly. Let me open my sensitivity study here. So this is, I'll just again briefly go through the model a little bit. This again a parameterized file type. I'm parameterizing some of the inputs in the input file to PSIM simulation, and this through this PSIM simulation, I'm changing some of the components like the inductor, capacitor, resistor, etc. And my outputs are max and min of both current and the voltage output. And after I run my DOE in post-processing, nothing has been changed. Again, we still go to Pareto plot. Now in the menu option, we're going to have the third one called variance-based sensitivities, GSA. In here, and if you pay attention to the correlation legend here, we have a third option now, third indicator, which is a solid field, and which is represented by this letter O, which means like there's no directionality in the influence. So we get the absolute value of the influence, and this is the nature of the Sobol analyses. Like I said, nothing has been changed. It's still the same, and you still have the ranked inputs and etc. for selected responses or all responses in the study. This is not the only area that you will have the sensitivity analysis. You might have a fit model. Once you build a fit model, you can go to diagnostics. And in diagnostics, you'll have the sensitivity analysis, like a dedicated area under the diagnostics. You can pick the response, and you'll see all the percentage of contribution from each variable. Another enhancement will be regarding the vector predictions. So far, the FAST was only applicable to a scalar type of responses. Now we extend the FAST algorithm to support predicting vector data. So obviously that's going to eliminate the burden of picking the right method for the particular data source. Basically, it will just bring the whole convenience of the FAST algorithm to every type of response round we have. And a second enhancements in the vector area is defining the objectives directly on the vector responses. So as the importance of vector type responses is becoming obvious, we implemented a way of defining objectives directly on the vector data. This will bring the convenience of skipping the entire scalar response step and working it out straight from the data sources. It's just we help, to set up the optimization problem. Currently, the underlying optimization methods do not take advantage of this yet, but it's obviously, definitely in our plans, and we're working out with the people responsible with the optimization code, and obviously we're gonna get it to be consumed by the optimization method directly, and calculate all these necessary pieces like sensitivities and stuff straight from the vector data. I can quickly demo this as well. So when you go to the objectives and constraints tab, when you create the goal now, in the apply on list, you have the data sources available. And we have 3 types that are applicable now: maximize, minimize, and constraints. In maximize, it will basically maximize either the minimum point of the curve data, or it will just maximize the average of the data. And similar to minimize, it will minimize the maximum point or average of the entire curve. And the fourth option is for constraints. And in constraints, we have basically 2 options for now. This will ensure that every single point, in the curve data or vector data will be above this threshold, at least equal and above, or equal or less than the threshold value here. But you still have to have some sort of a scalar response anyway to proceed to the next step. But in terms of setting up the optimization problem, this is at least a convenience of skipping that part for that particular response definition. Okay, here's another improvement in the methods and tools. When we stopped the evaluations until this release, it was all about stopping it and bring the whole, the evaluation process to a halt. Now we're introducing like termination options, like depending on obviously it depends on the approach type, because every approach has its own particular exclusive behavior. For example, in DOE, you'll have stop and finish evaluations. Stop is stop, and finish evaluations will wait for every evaluation that has already been executed. And for optimization, again, the similar story. You'll have the stop finish evaluations, or you can wait for it to finish the entire iteration. For fit, you can again stop, or you can do stop and analyze the data, and so it'll give you some the whatever fit model with certain diagnostics, or you can wait the evaluations started by the process. And in sampling fit, it's a little bit complex. You can stop and build the fit models, or you can finish the evaluations and build fit models, or similar to optimization, you can ask for it to finish iterations and build fit models on top. It's basically when you go to evaluation step, when you start evaluating, when you hit that stop button, it will just give you all these different options for the terminating the process. Okay. We also have some improvements in the purge tool. As you already know, in the purge tool until this release, we had a predefined list of files and folders to be purged. Now we're just getting rid of this whole system, and we're introducing a wildcard based search. As you can see in this image here, doing star.out, and it just finds the every single file in the run folder with the out extension, and purging upon the finishing the whole process. Or you have the option of selecting files or folders through a browser. As you can see here, select files and select folder options here. So these are some improvements in the purge tool. The last one in this area, methods and tools, is the handling of hanging sub-processes. Child processes, as some of you have already experienced, may cause disruption in a multitask environment. So when they're not terminated by the main process, it prevents products like HyperStudy from proceeding to a next evaluation point. To overcome this, we already have a solution. We internally limit the waiting time for each child process up to 10 minutes, but the configuration of it has never been exposed to our users. Now, if you go to evaluation parameters in the evaluate node, you will have the 9th option dedicated for the timeout, a limit for the child processes. The final category is the post-processing and visualization. A while ago, we introduced media sources where one can visualize images of any related information produced by the solver processes, such as a cross-section of a motor configuration in Flux2D, or hotspots from HyperView. And now we're introducing the visualization capabilities for 3D simulation model and results. The setup experience is going to be like the contour section HyperView. And in terms of supported result formats, it's the same as HyperView. So whatever the HyperView supports in terms of result files, we support them as well. And this will also be demoed. Okay, so once your solver process produces some meaningful or readable output files by HyperStudy, when you go to define output responses, now in media sources, let me start from scratch. You can add the media source manually, similar to what we had for images. And we have now types, image, and 3D visualization. In 3D visualization, when you browse to a file, an HTTP file here, and we have this tool settings. Once you click on it, as I mentioned earlier, the setup will be very similar to what you see in Hyperview. So we have this dedicated area where you can pick subcases, steps, types, components, and etc. If you have layers such as the composites and etc. The second column will be dedicated to averaging methods, or we have this corner data option here. And the third one is the control for the customization for the legend. Again, like I said, this is a 3D model. You can rotate, zoom in, and etc. Or you can turn off the preview somehow if you don't want to see it in the graphical area. You can reverse the legend. Once we have that in DOE or any other approach type, in the post-processing step, we have a dedicated tab for media type of responses. And you can one by one go through the iterations or evaluations and see the change simultaneously in the graphical area. Again, you can rotate. If you want to do any change on the legend area, you have to go back to the media sources and fix it from here and make your changes, and it will automatically apply those changes in the post-processing area. Here, again, similar to images, you can pick all of them and you can animate through. Imagine this an optimization is converging to a solution. That would be nice, like to see the progression of the contour results on the model itself. And you can do multi-plot again. And also we in the option menu here, we have some control over the visualization for both geometry and mesh. You can bring the transparency, or you can bring the wireframe, or in mesh mode we have the feature lines and we have the mesh lines option. Again, you can use that in the side by side as well. Well, they're not synchronized, but if you want to look at a tabular data or some sort of a scatter data, maybe maybe in the future we'll work on it to maybe synchronize them. But currently they're not synchronized, but you still have the option in the side by side. This is all I have for the enhancements on all these improvements. And the last part is for bug fixes and stuff, or some announcements to make. We have two major fixes that we can mention here, which is noteworthy. Maybe there were some numerical discrepancies in tutorial HS 1610. We fixed it, and undo action was not working for if you remove the models, and it wouldn't have brought the model back. So it's been fixed. And also for those for those who are using XOpt as an external optimizer option, or the customers of that using XOpt as an external optimizer route, it's going to be deprecated in 2024. Please let them know. And we highly recommend that you switch to a Python route using Python API.